Hello student, today my lecture topic on Schrodinger wave equation. In this topic, basically, we will discuss the derivation of Schrodinger wave equation and also we will discuss the property of the wave function. As per de Broglie hypothesis, the dual character of the matter, the Schrodinger proposed the wave equation to calculate the wave function associated with a particle. The Schrodinger wave equation is the fundamental equation of the quantum mechanics in the same sense that the second law of the motion is the fundamental equation of the Newtonian mechanics. Okay, all of you know that the traveling wave equation can be written as like that: d square psi ds square is equal to 1 upon a b square d square psi dt square, which have already discussed in a previous lecture. Now in this equation, you know that this means the v is the velocity of the wave, and now the solution of this equation can be written as psi is the function of t, can be written as a sine omega t minus x upon a v or a cos omega t minus x upon a v. Okay, now we can write this wave function like that: a e to the power plus minus I omega t minus x by v. Okay, now suppose we assume that wave is traveling in a positive x direction, we will take the negative like that: xt a e to the power minus I omega t minus x upon a b. Now this equation 1 and this is the solution of equation 1 is equation 2. Now you can see here, this is equation for traveling wave, simply wave. Here is the solution of traveling wave. Okay, now the Schrodinger suggested that the wave function can be represented as simply wave function, but the energy and wavelength of the wave function can be represented by Planck constant and de Broglie wavelength. What does it mean? It means that suppose that we can write the solution like that: xt a e to the power I 2 pi is mu t is mu x by b, like that. We can write that a 2 pi by I mu t. Now this mu by v can be written as x by lambda, because all of you know that mu dot lambda is equal to v. So we can write that 1 by lambda is mu upon a v, like that. Okay, like that. This is the equation number 3. Now equation 3 is also a wave function of a wave. Okay, as per suggestion of the Schrodinger, the energy and wavelength can be represented by a Planck constant and de Broglie wavelength respectively. It means that energy, what is the energy of Planck constant, is h into mu. It means that mu can be written in E by h, where h is the Planck constant, is the energy of the wave. This energy of the wave associated with a particle. This is the energy of the wave associated with a particle, and the wavelength can be represented by a de Broglie wavelength is h upon a p. Okay, we can write that 1 upon a lambda is p upon a h. Now this one and this one is the energy and wavelength associated with a particle. Here this wave function, it is only for wave. Now as per this suggestion, as per the suggestion by the Schrodinger, and put the value of mu and lambda in equation number 3. Now we can write the wave function xt a e to the power 2 pi by I, where mu is e t divided by h minus 1 by lambda p x h. This like that. We will take the common of h, a e to the power 2 pi by I by h. We can write that et minus px. Also we can write that e or I is I divided by h cut et minus px, where h cut is equal to h upon a 2 pi. Okay. Now this equation number 4. The equation number 4. Now the equation number 4, we can say that this wave function can be represent a free moving particle. Now question is that, suppose that the particle is subjected to the external field. Now in this situation, this equation is not valid. This equation 4 is not valid because this equation is a represent for a free moving particle. Okay. Now in this situation, we obtain the differential equation, and this differential equation is known as a Schrodinger wave equation. And when we will solve the differential equation, we will get the wave function. Okay. Now in this way, we will find the wave function when the particle is subjected to the external field. Okay, fine. Now the question is that how we will find the definition equation. There are two methods we will find the definition equation. Now what is the method first? The method first is method. Now in this method, all of you know that total energy of the particle can be written as E is equal to kinetic energy plus potential energy, because we will consider that the particle is subjected to the external field. So we will consider the potential energy. Okay. When the particle is free, we will not consider the potential energy. Okay. Now when the particle is free, in this situation, the wave function can be written as like that. This wave function associated with a particle here. Okay. Now, when we consider that particle is subjected to the external field, we can write the total energy of the particle is kinetic energy plus potential energy. Like that, we will write that half mv square plus v is the potential energy. Okay. Now this is equation number 5. Now we can write the equation 5 like that is p square by 2m plus v, where p is the momentum of the particle. Now we will multiply both sides by the wave function psi. We can write that psi is p square psi 2m plus v psi. Now question is that what is the value of E psi and p square? Now this value we can obtain by this equation 4 by simply first derivative with a time we will obtain these values, and when we will take the second derivative with position we will get these values. Now here you can see here like that. Now first we will take the first derivative of this equation 4 with time. We can write that minus I h cut a e to the power minus I h cut et minus px. We can write that e like that, and all of you know that I h cut, this function is psi, is e into psi. We can write that e into psi is equal to I h cut d psi by dt like that. you will obtain these values. Okay. Now, when we will take the second derivative of this equation 4, we will obtain the value of this one here like that. Now d psi by dx is minus I h cut a e to the power I h cut e t minus px. Here will be a minus p. And now the second derivative is I h cut I h cut a I by h cut is e t minus px is minus p, again minus p. Now you will see that this minus plus and I square is also a minus. Here yes plus is a p square is a h cut square. This value is a psi. Now the value of p square psi is equal to minus h cut square d square psi by d square. Now this value is here. Now when we will put these two values in this equation number 7, now you will see that here the value of into psi is I h cut d psi by dt is equal to value of the p square by is minus h cut square divided by 2m d psi by dx plus v psi. This equation is known as time dependent Schrodinger wave equation. This equation is known as time dependent Schrodinger wave equation. Now, what is the time independent Schrodinger wave equation? The time independent Schrodinger wave equation means when the potential energy is the function of position only. Okay. In many problems, the potential energy can be depend only on the position, not on the time. It means that now in this situation, we will see that only these values, this one will be put in this equation. It means that E into psi is h cut square 2m d square psi d square plus v into psi. Now we can write this equation like that: h square 2m d square psi ds square plus e into psi minus v psi is equal to 0. H cut square by 2m psi ds square is plus e minus v equal to 0. Also we can write that is equal to psi ds square is plus 2m h cut square e minus v is equal to psi is equal to 0. This one is known as a Schrodinger time independent wave equation. It means this equation is known as time independent Schrodinger wave equation. Okay, this one is the method 1. What is the method 2? Now in a method 2, in a method second, okay, all of you know that this is equation for traveling wave equation. Okay, now the solution of this traveling wave equation can be written as xt a e to the power minus I omega t minus x upon a v, where v is the velocity of the wave. Now we can write this a e to the power minus I omega t minus omega by bx. Okay, all of you know that velocity of the wave can be represented by omega by k, where omega is angular frequency and k is the wave propagation, wave vector, and the value of the k is 2 pi by lambda and omega is 2 pi by mu. So now we can write here, you can see here, now omega by v is equal to k. We can write, okay, when this value will be put here, now the wave function can be written as a e to the power minus I omega t minus k into x. Now you will take the first derivative with respect to time of this equation, written as d psi by dt is equal to minus I omega a I omega t minus ks. Now the second derivative, d psi by dt square is I omega and again I omega a e to the power minus I omega t minus kx. Now, okay, we will write here minus omega square. This one is the wave function psi. Here we can write that I omega psi. Okay. Now the value of d psi by dt is equal to minus I omega psi. Now the value of the second derivative, when we will put this value in this equation, so you will see that d square psi d square is b square minus omega square into psi. We will write that omega square is b square in minus is psi. All of you know that omega square here. Omega square b square is a k square. Now d is equal to psi a d square is plus k square, psi is equal to 0. Now this is the equation for wave, not wave associated with a particle. Okay, because k is the wave propagation or wave vector. Now the concept of the de Broglie wavelength, lambda is equal to h upon a p, and all of you know that p is equal to h upon a lambda when we multiply and divided by the 2 pi by multiply here and divided by 2 pi by here by a lambda, and all of you know that the value of this quantity is known as h cat, and we can write that h cat 2 pi by lambda, and all of you know that the value of 2 pi by lambda is k. Now value of this one is k, so we can write that h cat k. Now k is equal to p upon a h cat. When we'll put this value here, d is equal to psi and ds square is p square h cat square, psi is equal to 0. Now this equation number is 1, this is a 2, this equation number is 3. Suppose that this equation number is 3. Now this equation is the wave function of wave associated with a particle, because we will use the concept of de Broglie wavelength. Here this equation 2 is a simply wave equation for wave only. Okay. Now suppose that all of you know that the total energy can be written as half p square by 2m plus v. Okay. Now the value of the is equal to 2m E minus V, where V is the potential energy and E is the total energy, and we will put this value here in this equation number 3. So we can write that d psi by d square plus 2m E minus V psi divided by h cat square is equal to 0. Okay. Now we can write that d psi square and d square plus 2m divided by h cat square is E minus V equal to psi is equal to 0. Also we can write that h square by 2m d square to psi d square plus E minus V psi is equal to 0. Now this equation is known as a time independent Schrodinger wave equation. This one is known as a time independent Schrodinger wave equation. Okay, which have already discussed in a method 1. Now, what is the time dependent Schrodinger wave equation? Now, in this case, the time dependent Schrodinger wave equation, simply we will put this value. This is suppose this is equation number. Suppose that is equation number 4. Now, when we put this value in equation 4 here like that, you can see here this equation here d psi by dt is equal to minus I omega into psi. Now we will put the value of the omega with the help of the Planck constant. E is equal to h cut omega, and omega is equal to E upon a h cut. Where we'll put this omega value here, I E divided by h cut minus I is psi. We can write that A into psi is equal to h I d psi by dt. Okay. Now we will put this value here, h cut square 2m dk square psi ds square plus A into psi minus v into psi is equal to 0. The value of is equal to, we can write that h square by 2m, this is equal to psi, and ds square is is equal to I h cut d psi by dt minus v psi is equal to 0. And now we can write that like that. I h cut d psi by dt is equal to minus h cut square by 2m d psi by ds square plus v into psi is equal to 0. This one is known as, this equation is known as time dependent Schrodinger wave equation. Okay. Now, what is the property of the wave function? Properties of wave function. Now, what is the property of the wave function in a quantum mechanics? First property is it must be finite everywhere. Second, it must be single valued. Third, it must be continuous and must have continuous derivative everywhere. Now these are the property of the wave function associated with a particle. Okay. Now I will stop here, and next video lecture we will discuss the application of Schrodinger wave equation. Thank you.